Hello and welcome. Today we are continuing our talk on probability. We're going to be looking at what's known as compound events, which means we're going to be looking at probabilities that multiple things happen at the same time. So what we're going to need to do when we're setting up these problems is first determine whether the events are dependent or independent. And as the name suggests, independent events are things that do not affect each other. Dependent events are things that do affect each other. So, example of independent events would be something like the weather outside and the day of the week. Okay, so we know that it can have any weather on any day. Those things do not have any effect on another. For dependent events, it could be things like where you live and what sports teams you like. So those are things that are related to each other in some way or another. So before we can get into calculating probabilities, we probably need to be able to identify events as dependent or independent by sort of reasoning our way through the situation. So one coin is tossed, and then a second coin is tossed. These events are going to be independent because flipping one coin has no effect on flipping the second coin. For the second one, it says in the class presentation example above, one student's name is drawn and not replaced, and then the second name is chosen. Well, if I draw a name out of a hat and I do not put it back, that has an effect on the second one drawn because now there's fewer names in the bag or the hat or whatever I'm drawing from. Also, I can't use the same name twice, so that limits the number of names on the second draw. So these events are going to be dependent. And finally, lottery numbers. Wednesday's lottery numbers and Saturday's lottery numbers. Since we are not pulling from the same draw, they should not have any effect on one another. So the lottery numbers that get pulled on Wednesday are independent of the ones that get pulled on Saturday. So as you can see, a lot of these end up being just sort of reasoning through the situation. Independent, the events have no effect on each other, and dependent events, they do. Alright, so for two independent events, the probability that the two events happen at the same time is the probability of the first event times the probability of the second event. So again, you're going to find the probability of the two events, multiply your answers together, and that will give you your answer. So if we look at the example 2, we've got some colored slips of paper. Marisol and her friends are going to a concert. They're going to pull the slips of paper, they're going to put the slips of paper into the bag, and then everyone's going to draw a slip. Yellow means you ride in the van. Blue means you ride in the car. And we want to know the probability that if Marisol draws a slip and puts it back, then draws a second time, what is the probability that each slip is blue? So basically, we need to know the probability that we draw blue twice after putting the first slip back. So if you look at the picture, there's 3 blue slips, and there's 5 yellow slips. So if she draws a slip out, the probability of getting blue is 3 over 8, because that if with 3 blue and 5 yellow, it tells us there were 8 total. If she puts the blue back and draws again, there's still 3 blue and 8 total. And so now all we're going to do is multiply this together. And that's our answer. For dependent events, the probability of both events happening at the same time is the probability that the first event happens times the probability that the second event happens, given that the first one already occurred. So that sounds complicated, but really it's the same thing we were just doing. We're just not going to have the same fraction twice. So if we use the same setup as before, we're going to draw out 2 slips, but this time we're not going to put the first one back. So we're starting out with 3 blue, 5 yellow, 8 total. So the probability that the first one I get comes out yellow is 5 out of 8. If I do not put the yellow slip back, that means there are now 4 yellow slips remaining and 7 total. So we multiply our fractions, reduce the answer, and we should get 5 out of 14. And then for example 4, and this is a conditional probability. This is also called the probability of something given something. So the probability that B given A is the probability that they both happen divided by the probability that only A happens. And it sounds complicated, but really when they give you a given statement, it's basically telling you to use the second thing as your total number of outcomes. So if we look at this, we've got a set of numbers from 1 to 8. Students are going to draw a random number. If you get an odd number, you're on the proposition team. If you draw an even number, you're on the opposition team. And we want to know the probability that if Jonathan is on the opposition team, that he drew a 2 from wherever they drew the numbers. So if Jonathan is on the opposition team, that tells us that he had to have drawn an even number. So when I'm sort of listing out my pool of options, I'm only going to write down the even numbers. So we know the evens are 2, 4, 6, and 8. So if I know he drew one of those 4 numbers, and I know that I want to know the probability that he drew the 2, the probability is 1 out of 4 because there's 1, 2, and 4 total numbers. And that's all there is to it. So again, you're just going to take the given statement to narrow down your total number of options, and then find the probability of the thing you want happening based on the options that you already have. And that's all we have for today. I'll see you guys next time.